Good afternoon, everyone. I stopped by the store and I picked this up for $15. Apparently I'm on a Sanyo tear. This is the second Sanyo thing I found. This looks like, what are we saying, mid-80s maybe for this? We'll have to look it up. This is in very nice shape, just a little bit of dirt, a couple of minor scratches here. The speakers look fine. It's got the little piezo tweeters that probably don't do anything. At the top, all the knobs are present. It barely fits under the camera here. And so, volume, tone, to cassette, the play deck and the recording deck, function switch, mode, the dial turns just fine, and yeah, if I looked in the cassette mechanisms, I don't think this is going to show at all, but they're very clean. In fact, the whole thing is really clean. There isn't any dust on the front of this. It doesn't look like there's a lot of dust inside the speakers. There's some dust on the very top of it, but not on the front. And if you look in the grills at the back, I really don't think you can see this on there, but it looks pretty clean inside. Here, was it ever used with batteries? I doubt it. And it takes 1, 2, 3, 4, 5, 6 C cells. We'll leave that off for the moment. Now, it also takes a power brick, and I have a more or less period correct power adapter. This is a 9 volt, 650 milliamp, 6 batteries, 9 volts. I think I looked at this in the store, and I think it is center negative, but this is reversible. So we will check that with a meter before doing anything else. I have a tendency when at the, dealing with any sort of used electronics, to pick up linear power supplies of interesting and useful voltages. I think this is probably not an uncommon habit for people with a bit of a radio collection. The reason for that is that linear power supplies tend to be better with radios than switching power supplies, to the extent that some Texan stuff still ships with linear power supplies. I do note that my Sanyo 909X2 shortwave radio shipped with a switching power supply, but I haven't really been able to notice any problems with it. So obviously some of the better switching power supplies are fine. Let me just have a look. Oh, you're not going to be able to see this at all, but this is the power side, and it's got a headphone jack and a power supply, and it is center negative. Okay, so let me get the power supply plugged in, figure out whether it's set for center negative or center positive, and then I will come back. All right, here we go. I've got the multimeter out. I think I have it set for center negative, but let's find out. So center negative is, that should be the positive, that should be the negative. Oh, it would help if I had it on DC. And it's run up high because it's a linear supply, but that will go down to 9 volts when there's load on it. I have used this with other things before, so I'm not super concerned about using it in this context. Okay, so I will turn this around. I want to point out that the only thing that is wrong with this is the antenna is broken off on the end. It's right here. Probably won't matter in my use if I find this. I mean, this is going to clean up so nicely, I may try to get an antenna for it. Okay, so let's plug it in. All right, and let's turn the radio on. Okay, we got nothing. Let's just check the power once again. I may have managed to pull it loose. Yeah, we have power. So let's try again. Okay, nothing. All right, let's try. Okay, so second step, let's get some batteries and let's assume that there's some problem with the power supply. Here are some batteries. Let's put those in and see what we get. Carbon zinc, because I actually kind of like these for old radios that don't get used a whole lot because they leak less than the alkalines. Well, let's see what we've got here. Let's turn on the radio. And we've still got nothing. Let's try the... Still nothing. So we've got something to repair here. Well, that's good, I guess. So let me flip this over. We'll take the batteries out and have a look and start tracing the power. I think we'll operate from the battery compartment first, and then we'll move our way through the rest of it. If someone's had this open, which it isn't obvious that they have, it's quite possible that they misconnected the power supply. That's easy enough to do in quite a number of these sorts of things. It's easy not to get it all plugged in correctly. And we'll get the batteries out and find a screwdriver. Well, that sounded like it hasn't been opened. I guess we'll see. Okay, looks like we got the back off. So let's see. It's still holding up this one. Yeah. Okay. Well, I can see over here we have two plugs for the power going in. I'm going to unplug those. Actually, no way. I'm going to leave those plugged in. I'm going to unplug the antenna, which I know is on the left one of those. Okay, so these are all long screws. It looks like the only short one was that one. Yeah. Well, it'll be obvious when they go in. Okay. So what have we got when we look in here? We've got a band switch there. That's the band switch. We've got a very simple radio approach. We've got only 2, 3, 4, 5, well, 5 transformers in here. There's the tuning condenser. We've got a date, 1986. So I'm correct, this is mid-80s. We have some parts that are omitted for whatever reason. We have a complete separation of the cassette mechanism from the radio. This is the radio. The radio chip appears to be a BA1335, and the other numbers below are 605099. I don't know how to read those, probably date code of some sort. And then there are a couple of other chip-like things. I don't know if those are, I don't know what those are. Some sort of integrated package to build the radio. If you compare this to, well, let me just reach it just a second. If you compare it to the GE radio here, and this is also a radio on a chip, but you'll notice that it's got a lot more passive electronics on it, and it's got 2 additional transistors. So it looks like they just got the active electronics are in the chip here. Here we see a lot more. There's just 1 inductor and a bunch of resistors, a few capacitors. So big change from 1978 to 1986. Well, it's quite interesting. Let's see if we can see any other dates. This is 86, 9/22, September 22nd. I can't see any branding on the cassette motors. Okay. So we've got the power coming in here from the batteries. Let me put the batteries back in, and let's see what we can do in terms of having a look at that. We've actually got 8 date codes on the plastic here. This is probably not going to show, but the black code here is 86 on that, and is this 12, 3 or 5? I can't. 12, 3, 1, 12, 3, 1. I don't know what that's all about. We know that this was made in 86. That's the manufacturing date, and everything is 86. So, fairly nice construction so far. I'm assuming this is going to go to the switch. I'm not going to take anything apart that I don't have to. I just want to see if I can follow the power from here into the cassette mechanism. So what's interesting about this is in terms of the design of something, even compared to the earlier Sanyo cassette player I looked at, is that looks more like a radio with a cassette player put onto this. Here, the radio is the separate part, and the cassette player is seems to be the primary device. Now, this looks like the record erasing head coming off. That would only come off on one of the 2 decks. But funny enough, there looks like a provision for turning on the erase head there too. That's neat. Okay, so let's put these batteries in the battery compartment. And let's see why we're not getting power anywhere. It could be something as simple as a bad switch. Let's get the batteries in, and we'll see. Okay, so we've got batteries in, and let's get the meter. Just put this over here. Can you see that? I have to. All right, so we've got the meter on. We've got it set for DC. All right, so these are, we'll assume Sanyo's color code is correct. So we've got 9 volts, if you can see between my hands there, 9.5 volts on here. Where does that go to? Okay. And so let's turn the radio on. We should probably see power here somewhere. It looks like this little cable. Where does that connect to? Under here, I'm guessing? Let's see if we can find power on any of that. My guess is we will not. Is this ground here? Yes, so that's ground. That looks like that's this pin here. So let's hold that. Let's have a look. So you'd expect to have power and then yeah, I suspect power is going over here somewhere else. Band switch. Okay, so let's take it. Okay, let's take that handle off so I don't grab it, bust something. Let's just hit rewind. We should see no voltage on here. Or this one, I'm not entirely sure which one I pushed. Okay, no voltage on any of that. We continue to see 9.5 volts there. And so I can't follow all that well where everything is going. But the power supply section is down here. Let's have a look. So is this, okay, that's the power rail. That's the power rail. And that is 2. Everything's going to read negative because I've got, you know what? This soldering is very funky, and that's right around the power in, and they're probably using the plug as a switch. So I am going to attempt to resolder that. So let me just get the soldering iron on, and we'll be back. As I wait for the soldering iron to warm up, I just want to point out how beautifully clean and nice this is inside. Not dirty. Really pretty easy to get at and everything. I don't think it'll be too hard to get this off if we need to, but before we do that, I'm just going to touch an iron to that and just see what happens. Okay, the iron's warmed up a bit. Let's see if we can, may not be warm enough to deal with this giant blob yet. Let's go a little bit, improve our thermal conductivity here. Okay, something's wrong here. I'm going to desolder this whole thing, and we'll have a look. Let me just find. Oh, you know what? I'll just use solder braid. Wasteful, but. So I think this trace is lifted completely here. Yeah, we got a bit of a mess. Yeah, let's see what we can clean off. And see what's supposed to go where here. That's what I'm looking for. Let's just get as much of this mess up as we can. Okay, maybe. All right, that's what I was worried about. Okay. Well, let's see what's supposed to go where and how. I think the only solution was going to be to lift this board off. It looks like, let's get the knobs off here. It looks like we can have it with 2 screws, so let's do that. Okay, we're up over here, but I need to get by the antenna here. Well, we can have a look at the belts while we're in. Okay, there we go, and we'll unplug this. And where did my marker go? Oh, well, it's keyed. So, okay. All right. So what do we got? Very simple. Single-sided. Lots and lots of electrolytic capacitors. Okay, that belt is probably gone. That one looks okay, that one looks okay. All right, so we will have to get that belt out. These ones actually look all right. So that means we'll have to lift these motors off and figure out how that releases. Actually, we just need to get the motors off. Okay, one thing at a time. Power first, and then we'll deal with the rest. So it's a single-sided board, and the question is where it was supposed to go. This is just the side plate. Let's just take this out before I melt it into oblivion. It's not clear to me what chewed up these tracks, but we can see where they're supposed to go. Let me slide this over and see if I can zoom in a little bit and slide this down. I want to keep the power plugged in. Okay, that'll probably work. Okay, so let's zoom in as much as we can, and I'll explain what I'm seeing. So it looks like this went across to here, and that's the power track, and it looks like it's broken there and here. So it looks like there was, and you know, that's coming up too, right? Not very impressive. So it looks like this goes all the way down here. So the trick would be to bodge that in somehow or another. We have one pin that's still physically holding the power in place here. So that's hopeful. And then we have this one. So what I'm going to do is I'm going to, and this goes along, this goes up like this to here, and this goes to here. So if I put a bodge wire from here to here, and one from here to here, we might have some success. So let me get a couple of little pieces of wire and see how that works. One way we could tell what's supposed to go where is with the meter. That's off screen at the moment, but it's on voltage DC. Sure, let's do that. Okay. So once again, we can see where the power comes in over here, like this. Right, so there's our 9.5 volts. Now I wouldn't be surprised if this, yeah, so remember I said it was center negative, so this is the sheath outside, and we're seeing, you know, the drop across a diode, right, between the two of those, probably. So that means that then there's our 9.5 volts. So that should be positive, and this is coming in here. That's got nothing on it. So this is the switch, right? So what's probably failed is one of these two. So I think if we, so this essentially acts as the switch in the, I don't know. Maybe. But those clearly aren't connected to anything, and they need to be connected to something. So I'm going to try soldering those in and see what happens. Okay, so you can see I put a little bodge wire across there and there. I've gone with black and red because I think those are that's what they're doing, but we'll see. I'm a little concerned about this here. I'm gonna get a little bit more heat on that just to make sure. There we go. I mean, the whole thing's just a bit of a mess because there's bits of the board coming up too. Oh, that now looks like the driest solder joint of all time. There we go. Try to okay. Doesn't look good, but maybe it'll work. Okay, so let's zoom back out. And let's see, let's plug the radio in. And let's see if we can get the radio to work. Oh. Okay, we have power. Can we tune?
That means that the earliest that NASA, many former and current astronauts
of the war in February, in the beginning of the active phase of the war in February, it was all about, our, soldiers fighting smart and
So we have power. I'm knocking one of the switches, and I have damaged the microphone in putting this back together, but that's fine. So what I'm going to do is we'll fix this microphone wire. I don't think you can see that. We'll fix this microphone wire afterward. That's very fine, and that's going to be a pain. But yeah, it pulled off when I was opening this up, and I'm shorting something, probably this little switch here, which is turning on, one of these is turning on the cassette mechanism. I could be knocking one of these ones too. Not to worry, that's fine. The next step then, okay, so this has fixed our power problem. So we solved one problem. The second problem is the problem that I'm sure anyone who's worked on an old cassette deck is expecting, and that's that we have to replace this belt. And I'll probably do that one too. These short ones look fine. So let's see what's involved in that. It looks like 1, 2, 3, maybe 4 screws. Let's take this one out first. Maybe I will pull the batteries for the moment. Because of whatever switch I'm knocking. I'll take a couple of those out. All right. I'll like this one. Okay. And then this one. That one's longer. I'll line it up here. That's just the meter shutting off. This one here. Okay, well, maybe leave that one on there. And this one here. I note the speakers say maximum 3.5 watts, nominal 2.5 watts, impedance 3.2 ohms. Okay, and now we can get at the belts. So we need those two. Yeah, I'm going to leave those ones alone. I think they're all right. I'll replace these ones. So let me go look through my belt collection and see what I've got. Okay, for the belt situation, I've got the right size, but this is, I don't know, a 7mm one, and that's a 1mm one, or a 0.9. So we'll go with it for now, but I'm not going to change the other ones. And I can always come back in here and replace it with the proper one later. So this will go around here, and this should straighten. Oh. So what you can't see is me going down trying to get it on the motor pulley underneath here. I'm just hoping. Oh, you know what? This one's stretched out too. Okay, so let's find another one. Let's do both of them. Right back. All right, well, I've got the belts on and I've got it back together, and it is working. Well, let me first show you the radio, or play you the radio. So let's plug the power back on. And I'll explain why I'm unplugging that in just a minute. And I apologize for keeping this upside down, but it's just easier with regard to that. So let's turn down the volume. We'll flip it over to AM, and we'll go to radio.
General delays across the GTA, no recent trouble, so happy Labor Day.
So, no problem on AM, on FM.
Thanks, man. As it does on the outside.
We're getting stereo.
Ultramax premium
We've got the battery light on. Right? Actually sounds really pretty good. Tone control works. Oh, so pretty impressive. All right, we'll put it back on tape. Now, I'll play both decks very briefly because I don't want to do some copyright stuff with this, and I do have the traditional fly-by-night tape here. So this is the play-only deck. Working. Actually sounds to me like it's a little out of alignment, but that's the play deck, so that's not a big deal. That can be fixed. Now we have the play record deck. That one's definitely in alignment. So that sounds great, actually. That's a very nice sounding deck. This is not a great tape to check WoW on Flutter, but let me show you something. We'll just take this out carefully. See what happened? We've got a bit of a mess here. The poor rush tape has been mistreated by the deck. What's going on? Well, let's just get that back there. Oh. There we go, all fixed. Now the problem is that if you look down in here, you can't see, but the capstan is still spinning even when the tape is stopped, and that's catching the tape as it's removing it and pulling it out of the shell. So that means one of the little switches that controls the tape movement in there has jammed when I put the deck back together. That's why this was unplugged before, because I can actually hear this motor going. So I'm not sure which switch it is. That means I'm going to have to lift this board off again and see if I can find that. But I'm running out of patience for that because it took me, I don't know, it felt like hours, but it probably was about 15 minutes to get the belts on these things. What I ended up doing was taping them onto the larger wheel and then just sort of forcing them onto these. But the belts seem to be working fine, even though they're a little small. I don't notice a speed problem, certainly on this deck. On this one, it's harder to tell. It's pretty good cassette mechanism. I really don't have any complaints with it in this kind of device. And actually, I think this is a pretty good sounding radio. Remember, in 1984, this was still not a terribly cheap device. I wouldn't be surprised if this was $100 in, 84 money at the time. That seems like about the right price range. So I'm going to take a break from this, and then I will take out a couple of screws and see if I can figure out which of the little switches I've managed to jam while putting it together. Hopefully that'll be obvious on sort of visual inspection. But I need a break from this for a little while before trying that. Well, after mucking around with this radio for a while, I've decided, well, first let's talk about what works, okay? Here we go. The radio works
Prices go to greatwolf.com.
fine on FM and on AM. There's no point in running through it. It just works just fine. If we turn the radio off, this cassette deck has a problem, continues to have the problem with the capstan spinning all the time, and something's jammed in it. I fixed a spring which had come off, but there's something jammed in that, and I ran out of patience, I guess is the right word, for taking apart the cassette mechanism without it all going pinging out on me. However, this cassette mechanism does work. I will show you that briefly before we get a copyright issue here, but we can hit play. Oops. Are we on a... Here we're...
Don't care if it's modern Alabama or...
Okay, it was working. I've probably damaged the wiring in putting that in, but this cassette deck was working. So my next step on this thing is going to be take the back off again and figure out the wiring on this is quite short, so when you muck around in the back, it's potentially can be harmed. So I'll see if I can get this cassette deck working, and then I'm going to, because this one was out of alignment, I'll then attempt to align this one. So that'll give us one working cassette deck. This one I'm going to think about and see what I want to do with that. So we'll try once more, and I'll come back after I've got that stuff done. Yeah, so here's the problem. This little wire's come off right here. Just the whole thing's been flexed over so many times. It's not happy, so I'll just solder that back in, put it back together. This is where I've clipped the ground wire, I think, from this motor, just so that it doesn't eat any tapes and, you know, spin constantly even when the power's off. I think that there's a transistor that controls this, and I think the transistor might be bad, but I don't know. It seems more likely that it's something physically wrong, because the whole mechanism seems to be jammed on that side, and replacing the transistor would be easy enough, but dealing with the cassette mechanism would not. So that's why I'm not going to do it right now. So just to show how we go about adjusting these cassette, oh, there we go. Never mind, the cassette door comes off just fine. The cassette tape goes in place, and what do? You hit play. This isn't an ideal track for this, so I'll switch to another one, but you get the idea. You play a track, generally you want classical music's good, which is probably what I will switch to, and then you just slowly adjust the azimuth of the head until you get, you know, the best sound that you can. Again, I'd be a little bit more careful doing that on a record deck, but this is just a play deck, so it's not really that critical. As good as it's going to sound is as good as it's going to get. I should add that on a stereo deck like this, one of the things you can also do is balance the channels, because of course as the head goes in and out of alignment, right, you'll lose one channel. Well, I mean, they should both go, but realistically you seem to lose one more than the other. So sticking your head in the middle when you do it helps. This one has come up very well. Nicely in alignment now, as far as I can tell. Next day here, and I decided to have another look at this Sanyo mini-boombox. And I went in here for two reasons. One is that I decided I wanted to change the other belts. So let me just, I've got all the screws out here, so let's just lift this out. I wanted to change these belts here, mainly because there was some slipping on rewind and that, so I thought, okay, well, I've got them, let's change them. And I also wanted to have a good look and see if there were any little switches that I missed when I assembled it. And I couldn't find any, so I decided to have a look at this circuit. So what I decided to do is this pin here, this is the ground, if I remember correctly, and this is the positive that drives the motor, and that's what's switched. And so I ran it up here, and there was a transistor, and as far as I can tell, it was open. Now, of course, because when you check it with a meter, you put a you put DC on it. Why couldn't I find it before? And it was just had to do with how I happened to have the probes in my hand, because I did pull out the transistor, and I'll show you what I found when I pulled it out. So here's the little transistor checker. Here, I'll zoom in a little bit. Here's the transistor I took out. The number is B698, which I had to look up because the pinout of this is different than the pinout of the transistor I replaced it with. I replaced it with whatever general purpose transistor I happen to have. Anyway, so we'll put this in here. We'll give it a test. And it shows it as 2 diodes. Right? 2 diodes. Well, that's A, not a transistor, and B, it explains why I found it open when I put the probes in one way and not the other. What I replaced it with is a 2N3906, which is a pretty standard PNP transistor. Not this one. This one I must have used in something else, but let's see, just to show you what a transistor, a PNP transistor, assuming this is in the right box, looks like in here. Yeah, so there you go. Doesn't look like a diode at all. Right? So as I said, the pinout of this is different than the pinout of this. So when you're doing a transistor substitution, you've got to look at the data sheets and make sure. And that actually took me a surprising amount of time to wrap my head around. So I'll show you, it's all sort of twisted here. Right? There's the replacement transistor, sort of twisted in a bit. And I did try this very quickly, and it seems to be working. Meaning that I turned it on and this motor wasn't spinning, and then I pushed play on this deck and that motor did spin. So that's the what we want. So what I'm going to do is I don't want to run it for a long time without the all the screws in, because the screws on this board do help to hold the whole mechanism together. And I'll do that, and I'm going to solder back on the microphone. Sorry, I'm getting text messages in the background from multiple devices, but I'm sure it'll wait a moment. I'm going to solder that back in and see if we can get everything working here. But I'm quite pleased. I couldn't find any switches. I thought it had to be a switch because this one is controlled directly by this switch here. There's no transistor, but this one isn't, and of course it has to be able to be turned on remotely for the dubbing to work, right? So it works differently than the other. And I didn't worry about making sure whether my transistor was a good match or anything. It's only being used as a switch. I'm sure I could have compared the data sheets more closely, but you know, it's working. I'm not going to worry about it too much. So I'm going to button this back up. I'm going to solder on the microphone, which I'll never use, but you know, let's be complete. Make sure that I haven't broken any of these off while I'm doing that, and see if it works. Okay, the microphone is soldered back on here. It's a bit of a mess, but not really much worse than it was originally. I doubt I'll ever use it, so it doesn't really matter. And oops, reuse that piece of tape to hold those wires down. Okay, so I will put the back on. The radio is plugged in. We just have to plug in the antenna, and that I won't button the back up completely until I've given it a quick test, and assuming that's okay, then I'll come back. I'm just about to button this up for the final time. I did one more thing. I replaced this 100 microfarad capacitor that was on the bottom of this motor. You can see it's sort of hanging off crooked to the side. It should be fine. This one tested fine, right? Tested great. But I couldn't get high-speed dubbing to work once I put it together, and I thought, well, I'll change the capacitor just because. And of course, once I had it off and tested, it was easy enough to put a new one in. So I did, and high-speed dubbing seems to be working. So who knows whether resoldering these connections here solved the problem or what? I don't know. The belts on this one still need to work in. These have worked in pretty well, and the wow and flutter seems to be reasonably under control. This one they'll need a little longer, but high-speed dubbing works, and we'll see how it goes. So as I said, I'll put this back together. I'll give you a brief demonstration of the tape deck. We tried the radio already, and I won't bother recording. You'll have to take my word for it that it records, and I'll be right back. Okay, so let's do our final test of this. So let's first test deck A. We'll go with the talking heads this time just to be a little different. We'll hit play. So that works fine. This is not a tape to evaluate wow and flutter because it's like all flanger on the guitars in there. And here's this one. So both tape decks work. As we demonstrated before, the radio works okay.
Don't understand for the life of me why you cannot decide between.
I've tried out dubbing and high-speed dubbing. They both work. I haven't tried the microphone, but it'll either work or it won't. Don't really care. Tone control works. Presumably continuous play works. That switch, the switch that switches it from one side to the other for continuous play works. The only thing that's not perfect on it is that the antenna has been broken off at the end at some point. It's kind of an odd length. I suppose I could find one, but realistically, that's going to be enough antenna for Toronto under most circumstances anyway. Could maybe put a screw in the end like every painter's radio everywhere. So I'm very pleased with this project, and let me just give you a bit of a rundown about what needed to be done on this. I had to replace all 4 belts, so there are 2 belts on each deck. I've replaced all 4 of them. I replaced this transistor right here. I replaced this capacitor right there. Probably should have done the other one, but oh well. And I also fixed the power connection where it had pulled off of the board, and I had to bodge around it. So that means there were 4 things that needed to be repaired on this relatively simple 1986 slim boombox. And it just goes to show you how an old device like this can have a number of different problems with it. I think either the always-on motor for the tape deck, or the power issue is definitely a non-starter, quite literally. But I think the continuous play problem on the tape deck might have been part of it. And I do wonder if the power got shorted or something and that off this transistor, but I mean, it's really hard to know what could have offed that transistor, maybe just bad luck. All right, well, I hope you enjoyed the repair of this little boombox as much as I did. Hopefully I'll have something else interesting to repair with you in the near future. Thanks for watching.